Hello then, welcome to this Pandas challenge. This is day 27 of 30. My name is Valentine and I'll be instructor. In this challenge, we are going to be going through another set of Pandas concepts that will be important when it comes to data analysis. So let's get started. The first thing that you need to do is to visit the description link of this video and click on the practice resource link. That should take you to a page that looks like what you're seeing on the screen. Once you get here, just sign in and have access to and go just to continue learning, and then you'll get to the sample practice notebook, which will look like what you're seeing on your screen, and then we can get started with the learning journey. So once you get here, the first thing that you need to do is to go to File, then save a copy in Drive, to save a copy of this notebook to your Google Drive. And then once you do that, you need to click on Connect. So I'm going to be using the practice notebook, which is similar to the sample notebook. The only difference is that it has more challenges, but the examples are just the same. So I've already connected my practice notebook, so do the same, and feel free to pause the video before you continue along with me. All right, once you do that, expand the prerequisite section and then click on the first code cell to import the Pandas library, and then we can get started. All right, once you've imported the Pandas library, so let's go through the first concept. So we might want to shuffle records. So assuming that we had a data set and we wanted to change the order of the records that we have, maybe we would want to have just some random records, or the records that we have randomly distributed across the data set, the data frame. Then we can first of all load the data set, and then we use the sample function. So this is the sample function or sample method, and we specify the frac parameter to 1, which essentially should allow for that particular process. So we'll shuffle our records by simply just using the sample method and setting the frac parameter to 1, and we can set the reset index column to just simply be able to have a Pandas data frame output. And we can drop the original records by setting drop to true. And essentially what we end up having here would be now the shuffled data, and that's what we've got. This is our data set, but it has data which is just shuffled. Again, what you're getting here would be different from what you would get if you use random state for the sample function or sample method. You should be able to get similar. So if I say random state to equal to 1, and you also do the same thing, the records that I'll be getting will be similar to yours. If you use random state to 2 and I use random state to 2, you'd be getting similar records. All right, pause the video and then work on the challenge. Moving on, we might want to plot time series data. So assuming that we have this data set that we would want to work with, it contains information about various farms. It has just different information: planting date, harvest date. So assuming we wanted to create a time series plot using this data set, so we would first of all, maybe if we want to work with maybe something like yield amount or any other type, it could be let's assuming we wanted to work with planting date, so we would convert that to a date time format. We can also do the same thing with harvest date, but to plot a time series plot, we can set the planting date to be the index, and then we apply the plot function to the yield amount column, the one that we want to use for our time series plot. That essentially would still consider planting date as the x-axis on the x-axis, and y-axis, that's yield amount. Then we set the title, the label for the y and for the x and y-axis, and also the figure size. So that's what we've got. All right, pause the video and then work on the challenge. Moving on, in some situations, we might want to calculate the measures of central tendency. These are mean, median, as well as mode, in order to just understand how spread out data would be, maybe in a column. So if we had this data set that contains information about crops, so this is our data set, and we wanted to calculate maybe the measures of central tendency, such as the mean. We would just select the column that we want and apply the mean method or the mean function. The same case with the median function and mode. Mode normally, without specifying what we have here, that's this position 0, would give us a tuple, but would not necessarily give us the mode itself, but by specifying 0, we would essentially get the outcome, that's the mode, and then we just print out those measures of central tendency. Right, pause the video and then work on the challenge. In some situations, we might also want to still visualize the distribution of numerical variables. So assuming that we had this data set that still contains, actually this contains just crops data, and we wanted to create a histogram for maybe a particular column, such as average yield column. So we would specify that column, get that column, apply the plot function, just like what we did in the previous section where we created a time series plot. Once we have done that, we specify the plot we want to create. It's a histogram by specifying the value for kind to be hist, the number of beans we want, the color of the beans, and the edge color, so the edge of those beans we want it to be black, and also the title. And we run that and we should be able to get a histogram. Right, pause the video and then work on the challenge. In some other situations, we might want to create a summary table that gives us information about the distribution of variables. So for example, if we wanted to create a summary table from this particular crop yield data table that contains crop type, that's a smaller table, summary table, pivot table, crop type on the right hand side with region, the values for region, so north, east, south, west. We can be able to use the cross tab function for that. So we would specify, let's say, the column on the left that's crop type, and then on one on the right that we want to perform to determine the distribution of those values, and we just apply the reset index function to be able to get the pandas data frame output. All right, pause the video and then work on the challenge. In some other situations, we might want to perform filtering using just now time data. So if we had this data set still again that contains information about crops, we would want to first of all ensure that our data is in a format that we can work with. So if we wanted to have dates, wanted to work with the date and filter records based on dates, there are many approaches. We've learned a few in the past, but this is a different one. So first of all, we need to have a date column that we don't really have one that works well. So we have year, month. So we can convert that to have the format shown here, where we have year, then hyphen, month, and it should actually essentially look like what we initially had in one of our data sets. Like we want our data to have such kind of a format. But in our case now we have just year and a month. So that's what we do here. We create a new column, date, that contains year and month, and then we drop the original columns, year and month. We don't need them for filtering for now. We set the date column, the new date column that we've created, as the index, and then we specify the time period that we want to use for selecting the record. So we want our date to have records between this particular time period. So this is the starting date, this is the end date, and what we have here is just double colon, and we display the extracted data. All right, pause the video and then work on the challenge. Moving on, sometimes you might again want to create summary tables, but now the approach here we're going to use is not similar to the cross-tab method. The cross-tab method assumes that what you have defined when you are creating a summary table on the far right is still a categorical variable, but here we would have group data first of all by crop type and then by yield, or a numerical variable on the right hand side. So it's basically a pivot table that we're creating, a traditional pivot table. So if we had this data set that contains information about crops and we wanted to create maybe a pivot table that contains crop type, we first of all group by crop type, and then we would want the yield, average yield for each crop type. Then we use the yield column, apply the mean function to the yield column, and we again use the reset index function to just have a pandas data frame output, which we have here. Pause the video and then work on the challenge. In some other cases, we might want to work with specific time zones. If we have data collected in a different time zone. So for example, if we had data that we would want to have the time in maybe Asia, Calcutta, then we would need to first of all convert the data that we want to convert to have a date time format. Then we would set the time zone. That's the we would localize the column itself so that it has an initial time zone. Then we convert now to that date to now the new time zone that we want using tz underscore time zone convert function, and we preview the data. So here the data set has some limitation. It would have been better if we had the time information or time component of this harvest date. But again, here the idea is just to learn how to perform daytime conversion or time zone conversion. All right, pause the video and then work on the challenge. Moving on, we might want to perform encoding, so replacing values for categorical variables to have with numerical representations. So if we wanted, in this particular case, assuming that we had these this data set again that contains information about crops, we have different categorical variables like crop type, region, soil type, weather condition, pesticide used. And if we wanted to convert those columns to have numerical representations, but at the same time take into account of some natural order, then we can use the ordinal encoder technique, which we would first of all import the class to be able to perform that from the sklearn library. Then we use the fit transform method from the encoder that we have created, and we specify the columns that we want to perform ordinal encoding on, and then we just replace the original values with now the new values, the encoded values, and display the output. Right, pause the video and then work on the challenge. Lastly, in some situations, we might just want to identify outliers within a data set, not and so that we don't get to work with data points that significantly differ from the rest of the data. Maybe in some such situations, maybe data could have been erroneously included. So might want to identify the outliers. There are many techniques that we can use. One of the techniques that we can use to identify outliers is the IQR method that allows us to specify different quartiles as well as the quartile range. So we would specify the first quartile as well as the third quartile, which would suggest that a majority of the points would be between those quartiles, and points that are outside what we define as a lower bound and an upper bound would be treated as outliers. So the lower bound would be, actually I mentioned something different. So majority of the points within our data would lie between lower bound and upper bound. And points that are outliers would lie outside. So they would be either less than the lower bound or greater than the upper bound. So yeah, so we specify the lower bound and upper bound, and then we get those values that have a specific column, maybe such as temperature, that has values greater than the upper bound or less than the upper bound. And if there are records with such, then we can treat them as outliers. And you can see here we have a few records. So temperature, you can see 175, but a majority of them have lower values, 32, 30, 20, etc. Right, pause the video and then work on the challenge. All right, so that's it with regards to this challenge for day 27. We hope you're able to get to practice a whole lot more when it comes to working with the Pandas library and getting better and better, and you're just much more confident in using the Pandas library. If you'd like to be informed when we post such future learning experiences, be sure to subscribe. And if you found this video valuable, be sure to leave a thumbs up. It just tells us that we're doing a good job. All the best in your learning journey. Bye-bye.